When a solute is dissolved in a solvent, the boiling point of the solvent is elevated by an amount delta Tb that turns out to be linearly related or directly proportional to the molality of dissolved particles in solution. In equation form, delta Tb, that change in boiling point as a result of preparing the solution, is equal to some constant Kb for the solvent that does not depend on the identity of the solute at all, times the molality of the solute in the solution times I, the Van't Hoff factor of the solute. Now, I want to draw your attention to m times I, the molality of the solute times the Van't Hoff factor. Since the molality of the solute doesn't account for dissociation, but I does, when we multiply the two together, what we end up with is the molality of dissolved particles in the solution. This is the total molality of all separated dissolved particles in the solution, and this is really what dictates or drives delta Tb. So you'll want to think carefully about I in general in problems involving boiling point elevation, freezing point depression, and other colligative properties. In this case, we're looking at a solute, vanillin, which is a discrete covalent organic molecule that's not going to dissociate in solution. You could verify this if you went and looked up the structure of vanillin. It's a relatively large organic molecule with no ionic bonds. The problem here asks us to determine the boiling point of a solution of some mass of vanillin and some mass of ethanol. So to do that, we're going to need to determine delta Tb and use the fact that the boiling point of the solution, let's call that Tb prime, is equal to the boiling point of the pure stuff, let's just call that Tb, pure ethanol in this case, plus the delta Tb, which is calculated from this boiling point elevation equation in the center of the slide. That's going to come later though. Our first step is to determine the molality of vanillin in the solution with ethanol. The definition of molality is moles of the solute. It's almost always going to be moles of the solute in the numerator of concentration measures, divided by, and here's the unique part, kilograms of the solvent. Note that this is the solvent only, not the total solution. To find this in this particular case, we're going to need to use the molar mass of vanillin. So we have the mass of vanillin used in the solution, and we have the molar mass, and so we can go pretty easily to the moles of the solute. So let's go ahead and do that, and I'm just going to leave that in the numerator here. That's 3.4 grams divided by 152 grams per mole in the numerator. That gives us the moles of solute. The kilograms of solvent, well, we have the mass of solvent in the solution. It's 50 grams of ethanol. This is going to end up, once we divide that by 1,000 grams per kilogram, as 0.0500, add the trailing zeros for significant figure purposes, kilograms of solvent. When we do this math, we end up with a molality of 0.447 moles of solute per kilogram of solvent. That's the first step, and we now have the molality of the solute in the solution. The I value is fairly straightforward. As we mentioned before, I is going to be equal to 1, so we can essentially ignore it in the boiling point elevation equation, although it's still very important to think about it. And then Kb is intrinsic to the solvent only, so this is a constant that just sort of belongs to ethanol as the solvent. The problem gives it to us. It's 1.22 degrees C per molal, or more explicitly, degrees C kilogram per mole, since we're dividing by the molality. Notice that the units of Kb are such that we end up with degrees C when we multiply by a molality. Of course, that's by design, since we need a change in temperature based on the left-hand side. So now we can plug back in to the boiling point elevation equation and say, okay, 1.22 degrees C per molal times the molality of the solution, 0.447 molal, times the I value, which is equal to 1, is going to give us delta Tb. This comes out to 0.545 degrees C. And now we can simply apply the relation we found earlier for the boiling point of the solution based on delta Tb and the pure substance boiling point. To find that, the boiling point of the solution, we're going to take the boiling point of the pure stuff, 78.5 degrees C, pure ethanol, and add the 0.545 degrees C change in temperature, giving us a final boiling point of 79.0 degrees C.